Hello everyone, I am Ayush. It has been a long break, so now I am back again solving graph basic problems. First is the binary first search DFS cycle detection undirected graph. We will be solving using DFS and also using BFS. And the fifth one will be detecting cycle in a directed graph using DFS today. So these five problems. So let's just try to go over it one by one. And yeah, these are basic but important problems. So if you're watching this video, try to solve by yourself first because these are the very basics and like foundations of graph. So in the BFS, you just need to remember to use Q. If you can recall using Q and just remember when we need to update the visited, other than that, we have to push the answer. These three concepts. No need to learn the code, only three things. If there's a BFS, we will be using Q. Other than that, we have to think, okay, if there's a wasted array, how we have to update it, how to put the value, the true or false. Other than that, we have to think, okay, where we have to push or put the values, when and where. Okay, really, where we have kept an answer vector here, but at which step we will be pushing the values into answer. Okay, other than that, this was a connected undirected graph, so I didn't need to use a loop for I is equal to 1 to number of nodes. Like here are 1, 2, 3, 5 nodes, so I have to use for I 0 to 5. But since I was connected, I can simply do this. Okay, and it was starting from 0 vertex. It was bit easy, so things got easy, more easier. Okay, so BFS, what you have to remember? First, that we have to use Q. Other than that, we have to keep a visited vector. So I need to think that when we are updating the visited vector, we have to think of this that logic. And other than that, how will we putting or pushing the values at which time? So just think of that part too. And there is DFS graph. Okay, in DFS, we will be using recursion. Okay, other than recursion, what we have to think? Okay, the same. We have to keep a vested array, and when we are putting the values, like where we are storing and when we are storing. Okay, only three part. So DFS, you have to remember that we are using recursion. Other than recursion, you have to think that okay, when really updating our values, like printing the values, you can think of just or putting in a vector, storing it, whatever you want to say. And third is when we are updating our visited, like okay, so no need to remember the code, just think of the concept. uh, this will get easier. Okay, and also this was a connected graph, so there was no need to use a loop, only starting with 0 worked. And then comes cycle detection in undirected graph. Okay, this is interesting. Cycle detection in undirected graph, first we'll do right using BFS, then we will go for DFS. Okay, so stick with it, it is very simple. So if you see in this problem, we have first given the edges. So from that we got the adjacency list. Okay, while getting an adjacency list, few mistakes to avoid. Like there's 2D vector here, so we can simply do 0, 1. There will be like a map, not map, like pair, vector pair. So we have to do edges I dot first dot second. It's very simple, but I do a lot of mistakes in these. Other than that, if there is a directed graph, we'll only use U, not V. Okay, you will easy, you can do so. So other than that, we have wasted, as we know. This part is very simple. Like we are calling for solve BFS or DFS. If answer is 1, return yes. If answer is no, then false. We are just checking for presence of cycle. Okay, if there is cycle present or not. Let's just try to look over it. Okay, solve BFS. We have kept a parent vector. The initial value was 0 here. Like I we started from 0. I from 0. Okay, so 0th node got its. Let me remove something. Okay, the 0th node got its parent as -1. Okay, we are just initializing here. After that, we are, since this is BFS, we are using Q. We are keeping visited, and okay, and we don't need to print it. We are just checking for number of cycles, so there is no answer here. And this is the same while we use while concept, like while can say loop we do in BFS or DFS. Sorry, we do in BFS. Okay, while Q not equal to empty, we got the front node, pop it out. So it's a value, not node. Then we checked name if neighbor belonging to adjacent of front. We will check if you have not visited, simply visit keep visit equal to true. Okay, parent of neighbor is equal to front, and put this neighbor into stack. And if else if we have visited the neighbor and this neighbor is not his parent, then it's true. This is the main condition here. If you can remember this part, I think this will be easy. Like for cycle detection in undirected graph, we we know that there is BFS. In those problems, we are keeping a visited vector. Okay, we are keeping as a list. Other than that, we need to keep a parent for the cycle detection and undirected graph. And directed both, we can keep a parent vector. Other than the parent vector, we just need other condition that our neighbor should not be equal to the parent, its parent. This is again some. This is, you will see exactly the BFS. This part is different from BFS, and we mentioned it. We need to keep track of parent, and this part is a bit different from BFS. And here we are updating our parent. This part is different. These few parts are extras, and because we are keeping track of the parent, also this condition we have to check that this cycle present or not. So इतना ही है, बस इतना ध्यान रखना कि पेरेंट हम यूज़ कर रहे हैं पेरेंट वेक्टर, उसके अलावा पेरेंट को यूज़ करके पक्का अपडेट तो करेंगे करेंगे। और इसके बाद चेक कर लेना कि क्या हमारा जो नेबर है क्या वो पेरेंट के इक्वल तो नहीं है। इक्वल नहीं है मतलब बात खत्म, ठीक है। पेरेंट ऑफ फ्रेंड, ठीक है, सही है, हाँ बिल्कुल ठीक है। अगर हम और डेफेस से करेंगे, डेफेस पता है हमें रिकर्सन होता है, डेफेस तो रिकर्सन जाएगा, ये बात तो पता है। और विजिटर का भी यूज़ करेंगे हम, तो डेफेस में हम रिकर्सन यूज़ ही कर रहे हैं। और वी हैव केप्ट विजिटर तो रहेगा ही रहेगा। और यहाँ पे पैरेंट की जरूरत नहीं पड़ी क्योंकि पैरेंट हम इसी में रख दे रहे थे। पैरेंट एक वैल्यू होती है, उसमें सिंपली पुट कर दे रहे थे हम, किसी भी नोड के लिए कह सकते हैं सिंपल। तो विजिटर को हमने ट्रू मार्क किया, ठीक है। हमने लूप चलाया फॉर ऑटो नेबर एज लिस्ट ऑफ दिस वैल्यू, ओके। अगर विजिट नहीं किया है तो इसको ट्रू मारो, फिर डू अ रिकर्सन कॉल अगेन। और अगर वी हैव वेस्टेड एट नेबर, तो चेक करो क्या नेबर पैरेंट के इक्वल नहीं है। नहीं मतलब साइकिल बन गई। ये मेन कंडीशन होती है, ये हम याद कर पाए तो काफ़ी आसान हो जाएगा। नेबर नॉट इक्वल टू पैरेंट। और ध्यान देना कि मतलब पैरेंट सही से समझ पा रहे हो। यहाँ पे पैरेंट सही से हमने ऐसे पास किया तो पैरेंट इक्वल हो गया, बट यहाँ पे हमें टू पैरेंट मैप पैरेंट वेक्टर में फ्रंट मैप, अच्छा सॉरी, हम वेक्टर की जगह मैप बनाया, ठीक है, सही है, हाँ मैप ही होगा। पैरेंट वेक्टर से काम बनेगा क्या? वेक्टर से काम नहीं बनेगा, 2D वेक्टर बनाना पड़ेगा, ठीक है। या तो वेक्टर के अंदर पेयर पेयर बनाना पड़ेगा, ऐसे हो जाएगा, ठीक है। सिंगल वेक्टर से काम नहीं बनेगा। तो सोच पा रहे हो तो काफ़ी साइकिल एक्शन एंड ग्राफ क्या क्या चीज़ याद रखनी है। BFS से कैसे, DFS से कैसे। BFS मतलब पहले तो क्यू आ जाना चाहिए, क्यू आना जाना चाहिए, विजिटर जाना चाहिए। उसके अलावा क्या है, हमने पैरेंट का यूज़ किया, पैरेंट यूज़ कर रहे हैं पैरेंट मैप का, तो ध्यान देंगे कहाँ अपडेट करना है, कैसे अपडेट करना है, ठीक है। उसके अलावा एक सिंगल कंडीशन होती है कि हमारा जो नेबर है वो पैरेंट के इक्वल ना हो, नेबर जो है पैरेंट के इक्वल ना हो, ये सिंगल कंडीशन। सो हम DFS में, DFS मतलब क्या, रिकर्सन आएगा ही आएगा, तो रिकर्सन में यूज़ कर लिया। उसके अलावा विजिटर में यूज़ कर रहा है, ध्यान देना पड़ेगा कहाँ पे आप ट्रू करना है, कहाँ फॉल्स करना है, सोचना पड़ेगा इस बात में थोड़ा सा। उसके अलावा ये कंडीशन प्यारी होती है, यही सेम कंडीशन, नेबर नॉट इक्वल टू पैरेंट, ठीक है। फिर आते हैं हम डायरेक्टर ग्राफ में। तो डिटेक्टिंग साइकिल इन अ डायरेक्टर ग्राफ पहले DFS से करेंगे, बाद में किसी दिन BFS से बात करेंगे। तो सेम पहले एलएसएस लिस्ट बना ली। Since it was a directed graph, so we only use this as a list of A, pushback B. We didn't do as a list of B, pushback A. Okay, and one thing is extra here that if when we are doing in detect cycle in directed graph with undirectors, we are keeping an extra DFS visited. Okay, and this part is entirely same. This part is same. So you'll see there is only little difference. We are keeping a DFS val true and DFS val false, like backtracking part. You feel this. When using the condition here, we are checking DFS visited neighbor is equal to true, then return true. So just try to think this part, like capture this whatever you want. So you will see in undirected graph of DFS, this part is there. The other than that, what we have added extra, this part we have added DFS extra. This part is the extra. Other than that, here we're also checking that parent. Actually, this logic won't work here. Parent not equal to neighbor, so we need to remember this part. So DFS visited of neighbor is equal to true, then things will work well for us. Rest of the part is exactly same. Okay, great. So that's it for today. Let me see what we'll do like tomorrow. Okay, we can see from here. Here's the playlist. Topologicals what we had. Those are using DFS, Khan algo. For regulars on BFS, we can go for shortest path. In undirected and in directed acyclic graph. Okay, directed with no cycle. Then we have famous algos, Dijkstra's minimum spanning tree, Kruskal's, Bridges, articulation point, Kosaraju, and Bell and Ford. Okay, seven algorithms. Great, yeah. I think it will take 2 or 3 more days. Okay, that's it for today. Bye bye.